What we're going to talk about here is something called a repeated game. So if we take this coordination game that we had before, where Alice chooses between sports and comedy, and Bob, without knowing what Alice chooses, that's what this information set here indicates, that B1 and B2 are made with the same amount of information, Bob chooses between sports and comedy as well. What happens if we were to repeat this entire process twice? Well, what would happen is it would look something like this. So we would get the exact same process, and at the end of the process, we would have the outcomes as before. We would then, depending on where we are, so for example, if we're there, so if Alice chose sports and Bob chose comedy, so we're there, we would then replay the game here. Now, to be clear, what I have drawn there is a picture. It is a diagram that represents taking that first tree and essentially copying 4 copies of it underneath it itself. Okay, it is not an extensive form game. There are various reasons this is not an extensive form game. First of all, a simple one is that we have these leaf nodes that repeat. We have O1, O2 multiple times, O3, O4 multiple times. Now, what we would do to actually represent this as an extensive form game is make some modifications. So the first thing we need to do is not call this A, but call this one A1. Cool. Well, that doesn't really show, does it? Let me get a better color. Call this one A1. A1. Call this one A2. Call this one A3. And call this one A4. So now we have the decision. There are 5 nodes at which the first player, Alice, makes a decision. We also essentially get rid of these outcomes here. They don't really exist. It's just that when Bob makes a decision here, the next thing they do is go to either A1 or A2. But what we will do in these repeated games is add the utilities to all the outcomes. So there's 3 and 2, and so that means to these 2 outcomes, we'll add 3 and 2. So 3, 2 here will become not 3, 2, but 6, 4. 1, 1 will become 4, 3. 0, 0 will become 3, 2. 2, 3 will become 5, 5. And this will get repeated. We can indeed get all of them. This will be 4, 3. This will be 2, 2. And all I'm doing is taking the score of the first play and adding it to the score of the second play. This will be 2, 2. This will be 1, 1. This will be 3, 4. And let me keep going. We'll have a 3, 2 here, because adding that to a 0, 0, a 1, 1 here, a 0, 0, and a 2, 3. And then the final one will be essentially the reverse of the very first one. 5, 5, 3, 4, 2, 3, and 4, 6. Now, the other thing we just need to be a little bit careful of is at the moment, these outcomes repeat themselves. This is outcome 1, and this is outcome 1. That's not quite right. We need to change this. So this is O1, O2, O3, O4, O5, O6, O7, O8, O9, O10, O11, O12, 13, 14, 15, and 16. At which stage, now what we have is an extensive form game. So a repeated game, and what we're actually repeating here is a normal form game, because that information set, well, the equivalence is of course natural, but is a normally represented normal form game. We can then represent this as an extensive form game, where the players play once, and then all of a sudden, the game is repeated and the information sets hold. So Alice has 5 information sets. This A here, A1, A2, A3, and A4. And Bob has 5 information sets as well. This one here, and then this one here, this one here, this one here, this one here. So in other words, Alice and Bob both know what Alice and Bob did in the first round of the repetition, but not in the second. And so this is how we're going to study, and it's the right way to think of repeated games is as taking any game, including a game that's normal form represented, although there it is in extensive form, including a normal form game, and thinking about it, and you won't always be able to draw it, but thinking about it in terms of the corresponding extensive form game.